Lesson 5.3 Exponential Function. The general form of exponential function is y equal to b to the x. So here b can be any number which is bigger than 1 usually, because b can be fraction value as well, but if b is the fraction value, then we can also cover using the negative power or some of the powers. So usually we set up b is bigger than 1 here. Okay, alright, then now we want to compare fx equal to 3 to the x and gx equal to 3 to the x minus 1. Okay, so what do you think? What could be the difference between fx equal to 3 to the x and then gx equal to 3 to the x minus 1 power? So we want to using GeoGebra software, and then we want to compare those two functions. So now I'm going to show that fx equal to 3 to the x graph here. Now I'm going to also draw hx equal to 3 to the x minus 1. Then what do you see here? Yes, it looks like this farthest point moving 1 unit to the right here, right? Okay, what about gx equal to 3 to the x plus 1? Then before, your farthest was this point here. Now this y-intercept move 1 unit to the left, right? So based on this fact, now we can organize, especially these functions. We can say fx equal to 3 to the x move 1 unit to the right. And then similarly, we can also make, if hx equal to 3 to the x plus 1, then fx equal to 3 to the x move 1 unit to the left. Therefore, based on this fact, because base can be any value, y equal to b to the x, based on this graph, if we generate y equal to b to the x minus c, then y equal to b to the x moves c unit to the right this case, and then y equal to b to the x plus c, then y equal to b to the x moves c unit to the left. Okay, so then let's go back to GeoGebra again. What about fx equal to 3 to the x graph, and then ax equal to 3 to the x plus 1. So I'm going to turn it on, then let's see what happened. So what do you see here? It looks like this graph, this y-intercept point, move out 1 point here, right? And then now before, it never approached to x-axis, which means y equal to 0 line, but now this one never approached to, never passed through y equal to 1 line here. So to make you understand better, I'm gonna make this side and then zoom out more. So as you see, even though I zoom out more and more, it never passed through y equal to x. And then I'm gonna zoom in more so that you see it never touch actually x-axis. And then y equal to 1 graph here. So here, right? So like that. So based on this, we found out if we have a 3x plus 1, then whole graph move 1 unit to the up. Okay, so I'm gonna make a little bigger like this. And then what about this case then? Can you conjecture how this function behave compared to fx equal to 3 to the x graph here? So let me turn off this one, then turn on this. Then you see moving 1 down everything here. Okay, therefore we can summarize based on y equal to b to the x graph, y equal to b to the x plus c, then y equal to b to the x moves c unit up. And then now y equal to b to the x minus c, then y equal to b to the x move down c unit. We can summarize this way. Okay? Then what about compared to fx equal to 3 to the x and then cx equal to negative 3 to the x? Can you conjecture graph of this one? So as you see here, this is symmetric based on x-axis here. Therefore, you just make all this point, the y-intercept, before it was a 1, now become negative 1, and also it never passing through x-axis here. Okay, so which means based on y equal to bx graph, if is given y equal to negative bx, then reflect by x-axis. Okay, so that's the property here. Alright, then what about this case? So go to GeoGebra and I'm going to show one other different case here. So fx equal to 3 to the x power, and then now dx equal to 3 to the negative x power. So we found out cx case reflected by x-axis here like that, right? But the difference between cx and dx, negative power is on exponent position, not like with the number 3. Then can you conjecture the graph of this one? This graph will be this way basically. Okay, the reason is in all the positive number, then it become negative power value, and negative number will be positive number value here. So let me write for you here. So before y equal to 3 to the x, then and x and y negative 2, negative 1, 0, 1, 2, then we know that this become 1 over 9, 1 over 3, 1, 3, and 9 like that. Because 3 to negative 2 power means 1 over 3 square power here, right? But now, when we compare this and then y equal to 3 to the negative x power, then this becomes negative 2, negative 1, 0, 1, 2. You plug negative 2 into x, then this turn to y equal to 3 to the negative negative 2, which means 3 to the square power. However, if you plug 2 into here, then this is going to be y equal to 3 to the negative 2 power. So which means 1 over 3 square power, so become 1 over 9. So as you see, whenever you plug negative 2, then become actually positive power, and positive number then become fraction power here. So this become 9, 3, 1, 1 over 3, and then 1 over 9. That's what happened here. Okay? So therefore, the graph is symmetric by y-axis. Then what about this case here? So as you see this case, we have reciprocal of this one, right? So I'm gonna turn it on, then let's see what happens. So this one also symmetric by y-axis, right? Then now I'm gonna turn off original function 3 to the x, and then I will turn on maybe d function here. So what do you see? They are coincide each other, right? Which means 3 to the negative x power the same way as we can write 1 over 3 to the x power. And it makes sense actually. Whenever we have the property a to the negative n, then become 1 over a to the n here, right? Therefore, they are exactly same meaning. So, summary here, y equal to b to the x based on y equal to b to the negative x, then is reflect by y-axis. And another one, y equal to b to the negative x, we can rewrite that y equal to 1 over b to the x as well. Okay?